Hello everybody, I'm Rob Coleman, for those who don't know me. I'm going to be talking about VideoNuLA, which is an enhanced graphics card that I've developed for the BBC Micro. First of all, a bit of background. So, for those who don't know or can't remember, Acorn's 8-bit machines all had, or 8-bit BBC range I should say, not Electron, all had the same graphics chip, the VideoNuLA, sometimes called the VidProc. It looked like this. The one on the left is from my BBC B. It's the one with the heatsink. That was made by Ferranti's, a custom ULA, and there was an error in the mask and it ran hot, so it had that big fat heatsink on. I think I've seen some with massive heatsinks. The second picture is from a BBC Master. It's essentially the same chip, but this version was made by VLSI and it didn't have the problem. But in terms of capability, it's the same chip. So just to summarise, essentially there are 8 screen modes, 0 to 7, giving either 2, 4, 16 logical colours, which were then mapped by a palette within the chip to the physical colours, and there were 16 of those. However, the colour output was digital, so the red, green and blue guns are either on or off, and that means that the 16 physical colours were made up of 8 solid colours and 8 flashing colours, so you're very restricted. Lots of games and software use dithering to try to improve the range of colours, but certainly in the sort of lower resolution modes, and there's a trade-off between the number of colours on screen and the resolution. It's not particularly effective. So, I guess I got back into using 8-bit machines back in 2005. I started off in 1983 with the BBC B. A few years later moved on to the Master 128, then got an A3000, then a RISC PC, and I kind of got rid of all my 8-bit kit. And then I started doing some work with hardware in my day job, and was playing with some microcontrollers and didn't really understand them, and I thought, what's the best way to kind of learn about these things? And I thought, well, an 8-bit BBC Micro is kind of the ideal thing to interface them. So I got back into BBC, but whereas previously I was primarily interested in software, I was starting to do hardware stuff. And when I got back into it, I realised there was kind of a massive community, or pretty big community, and there were lots of sort of stuff going on, upgrades for more memory, upgrades for mass storage, SD cards, that kind of thing. That was kind of big at the time. But what there wasn't was anything around improving the graphics. And I just happened to pick up a lot of old Acorn user magazines, and flipping through them one evening, I came across an advert for Wild Vision's Palette Mate. And people might remember Wild Vision, they did a lot of Archimedes stuff. This was from 1986, I guess it was one of the earliest things they did. This was the advert. Could you use 16 colours in mode 2? I saw that and thought, yeah, I could. Probably can't read the text, but it says, essentially, had an analog palette of 4,096 colours, 16 solid colours on screen in mode 2, and I spent years looking for one. So scouring eBay, sort of looking at news groups and things. I even tried to email Pete Wild, who developed the thing, just to see if find out more details. I didn't get a reply, whether he thought I was mad or whether it was the wrong email address, I don't know, but I gave up. And then, kind of a few years after that, so this would have been in 2008 or something, I started thinking about, well, how would you go about building something like this? And the first obvious thing was it had to replace the VideoNuLA, because to get 16 colours on screen, you need access to the flashing bit. That's the top bit of the sort of 4 bits of colour information, and that's not exposed outside the ULA. So you need to at least recreate part of the ULA and possibly, the majority of it to get access to that. And then, 16 colours at part 4096 means you need 16 12-bit extended palette registers. You'd need some new registers to program the palette. Just doing some thinking about it, I literally on a back of an envelope, I started thinking, well, if you're going to set a colour, you need to give the 4-bit colour index, 4 bits of red, 4 bits of green, 4 bits of blue. That's 2 8-bit writes. And I started then just having a quick look with an oscilloscope on the BBC B, and I think the B+, the video ULA is mapped between FE20 and FE27 in the memory map, which would give you space for 8 registers, 2 of which are already taken, and they just replicate. But on the master and compact, you've only got, it's only mapped between FE20 and FE23, so basically you've got the 2 original registers and space for 2 extra registers. And then, this is essentially where I left it in about 2008. What about using some sort of CPLD, complex programmable logic device with a few hundred logic elements, just adding the figures up, 16 times 12, a few extra bits, emulate the existing video ULA, comes to about a few hundred in my sort of, wet finger back and envelope calculation. And then last year, about this time last year, maybe a little bit earlier, I actually had some time on my hands and started thinking about actually doing something about this. So, yeah, summer 2016. I built a breakout board to tap the video ULA signals. Really hideous thing that some people might have seen at the RISC OS Southwest show and the Wakefield show earlier in the year. The idea really was just to kind of, well, let's just see how far I can go with this, how much effort it's going to be. And I bought an Altera Max 2 development board, and the EPM 570, that means it's got 570 logic elements, which seemed about the right sort of size. Again, it's very much wet finger, could have been wrong, but it was just kind of, quick estimate. The big thing you have to do is, the BBC is obviously 5 volts, the CPLD runs on 3.3 volts, so all the signals have to be converted, so you have these level shifters. And basically what I decided to do was just mimic the behaviour of the video ULA 1 error at a time. So I wasn't trying to do anything sort of to enhance it at this point, I was just trying to see if I could replicate the behaviour of the ULA. And so this is taken off the VWiki. This is essentially the kind of main function. So you have the control register, there's the palette register, and basically the shift register. You're getting data in, and then you're outputting the red, green, and blue. There's some other stuff going on, the cursor, which is quite tricky. This is the flash bit I mentioned. You see that this kind of doesn't appear on the outside. You can only get at it. That's why you have to kind of mimic at least some of the video ULA. And that's the thing, that those 4 bits there are where you get your 16 colours from. The other thing it does is the ULA produces the system clocks, so 1 MHz, 2 MHz, 4 MHz, 8 MHz, and a clock for the memory controller, or the CRTC controller, which runs either 1 MHz or 2 MHz, depending whether you're in low resolution mode or high resolution mode. So the first thing I did is, well, they're clocks. They're pretty simple. I've got a clock on my development board, which was originally 50 MHz, but I swapped the oscillator to 48 MHz, and then derived those clocks. And then so I've got this oscilloscope, compared, clock coming out of my board, clock coming out of the ULA, and once they were kind of matched, I was happy with that, and I switched them over. The control register, this thing up here, it's an 8-bit thing. I got that working, so that's going to make sure that the board could be selected, and you could program the register. That was fairly straightforward. Again, palette register, this thing here, it's fairly easy to replicate. It's just a memory, and you just program it in some sort of way. It's like just different address. Again, this all happened really quickly. Actually, I got this working within, I guess, 2 or 3 weeks. I think I wasn't spending full time on it, but it was pretty straightforward. The hard bits were next. This thing, this video serialization, takes the data in and sort of does the lookup from the palette. It took me a while to get that going, although the documentation on the VideoNuLA was really useful. And the last bit is this sort of cursor control, really. At first I couldn't get that to work, so I left it out. There's no cursor, but I went back to it and actually found that I made a stupid mistake. It wasn't that far off. So all in all, this took me, I guess, from August until October, I think. I wasn't going full time, but it was, a few weeks. But nothing. I'd gone from someone who could read VHDL, which is what you program these CPLDs in, because I'd done that in my day job, but never actually written any, apart from getting an LED flashing, just getting this done within sort of a couple of months. So it really surprised me as a kind of software guy who hadn't done a huge amount of hardware, how much, there's so much material out there, and I had a friend who kind of done this sort of stuff and gave me some advice and things, but how quickly you can get some of this stuff going. So then it was a case of doing what I actually wanted to do, which was enhance the thing. So I added some extra registers. These two extra things I mentioned, FE22 and FE23. One's an extra control register, one's an extra palette register. And put in the extra palette, that was 16 by 12 bit thing that maps the physical colours to the new 12-bit analog colours. And I also put in something to retain flashing colours. And then, I guess we're talking, that took me, a week, I think. It was very quick. Once I got the actual VideoNuLA working, because I knew kind of what I was going to do with this, and it's new stuff, you can do what you like really, as long as it kind of works. That was very quick to get running, and I put a post on the startup forum in November showing 16 colours, a grayscale, and then 16 colours where I had the original colours and then their half intensity equivalents. And there was quite a positive response to that. People were kind of like, oh, this is good, and obviously I was really pleased, kind of done what I kind of set out to do. I replicated the functionality of the palette mate, 4096 colours, 16 colours on screen in mode 2. But there was still a little bit of space left on the logic device, so I was thinking about what I could do with it. And the guys in the forum were really helpful, because they had lots of kind of suggestions. One that came up pretty early was smooth horizontal scrolling. So if you know the BBC Micro, you can essentially scroll a byte at a time horizontally, which means that in mode 2, which is the one with the sort of the most colours, you can scroll 2 pixels at a time, because there's 4 bits per pixel. And in mode 1, you can scroll 4 pixels at a time, and in mode 0, 8 pixels at a time. What I wanted to do, and what I set out to do, was basically be able to scroll 1 pixel at a time horizontally. And that actually turned to be really easy. All you do is you just delay the output, and then it just shifts a little bit to the right. And obviously, if you want to shift it back to the left, you just decrease the delay. I'll talk a bit more about that later on. The other thing that came up was the idea of attributes. So other 8-bit machines like the Spectrum, Coleman 64, I think Auric, and various other ones, have this idea that alongside the pixel information, you have attributes, whether that's flashing or the colours or whatever. And I kind of thought, well, maybe do something like that. And then Richard Talbot Watkins took the idea of rather than running the modes at 16 megahertz or 8 megahertz as the BBC modes do, why not, because you've got a 12 megahertz clock on board for the teletext mode, run a graphics mode at 12 megahertz or 6 megahertz, and then because the memory is still running at 16 megahertz or 8 megahertz, you have additional memory bandwidth. So the pixel data is going at 12 megahertz, the memory is going at 16 megahertz, the extra information can be used as color attributes as a lookup into the palette. So the idea would be that you would have an 80-column mode with, instead of 2 colors, 8 colors. As I said earlier, I went to the RISC OS Southwest show this year and Wakefield and demonstrated the prototype, which was a really ugly strip board thing, wires everywhere. Well, lots of people laughing at my soldering ability. But it did work, and I had a lot of encouragement. And particularly at Wakefield, I guess people were sort of saying, oh, I'd quite like to buy one of these. So I thought about kind of the next step, which was getting into production. But bear in mind, as I said, I'm a software guy really. I dabble with hardware, I can solder a bit, but I've not really got any experience to get PCBs made. I'd kind of done some prototyping myself, through Hall stuff, but was pretty bad at it. And I'd never done any real SMD soldering, certainly not fine pitch stuff. I'd repaired my RISC PC when the CMOS battery leaked and things. I managed that, but yeah, that was about the sort of height of my skill levels. The real thing, I mean, the Max 2, the Altera Max 2 EPM 570, the pins seemed very small, and I was looking at thinking, you know, my stuff's not the best, and kind of, you know, doing this, thinking, I really fancy soldering that. However, I had loads of encouragement, and that's kind of one of the things I'll say at the end. Lots of people sort of said to me, "Oh, you'll be fine, just give it a go." And that really made me think, well, maybe I should give it a go. Even though I was kind of thinking, this is kind of not really my thing, it's something I'd quite like to be able to do. So I did. I got loads of advice from people on Stardot, Dominic Beasley, Jason Flynn. They kind of gave me loads of advice on PCB layout, how to use packages like KiCad, how to do the SMD soldering, you know, and they started to make me think, well, maybe I could do this. I mean, I know which end of the solder line gets hot, but that's how I look. And there's loads of stuff on the internet. You know, I watched loads of videos on SMD soldering and practiced a bit, and eventually started to think, well, yeah, this isn't as hard as I thought it was. So as I said, I got the board design reviewed by Dominic and Jason, and they came up with loads of good comments. The first one was, your board's too small, you need to make it bigger because you'll have a hell of a job, you know, debugging that if there's a problem, or even just the tracks might be too thin, so I redesigned it. And then I sent off to China for some PCBs, and they came back in May. And very nervously, I sort of took the first one, had the components ordered from the UK, soldered it up, kind of checked it with my kind of magnifying glass, and yeah, it looks okay. Amazingly, it worked, which was a big shock to me, to be honest, and a huge shock to my wife, who just couldn't believe that it worked. And I made about, I think, another 3 or 4 for myself initially. I mean, the soldering wasn't great on them, but they worked. I put them in my VBCs, and lo and behold, I had 16 colours, part 4096, which is what I wanted. You know, I spent years looking for the palette mates, and you know, it was in front of me. This is the board, just to kind of, so you can sort of see, but just to illustrate really that this top third of the board is the CPLD, the oscillator, and the digital analog conversion that does the colours. The rest of it, the other 2/3 are really interfacing with the BBC. So these are the level shifters that do the 5 volt to 3.3 volts. This thing is a Schmidt trigger inverter, which does the level shifting and cleans up the clocks a bit, just to make sure they're nice and clean and sharp. 3.3 volt regulator, there's some transistors that just do kind of some nice stuff. And there's a JTAG connector on the top to program it up. But really, you know, this is the thing doing all the work, and all this stuff is just there to support it. So in terms of where I got to, it's fully compatible with existing ULA. That was one of my goals. You know, I didn't want to kind of have a machine that could only, you know, do new stuff. I wanted it to be a BBC that would work just like my other BBCs. The reality is that the original software just isn't aware that it's there. So software expects to see the original ULA registers at FE20 and FE21. They're there. I haven't found any software that writes to FE22 or FE23. If there is software that does that, there's a facility within the ULA to actually turn itself off, so it doesn't map itself to 22 and 23, just any of its original stuff. But I haven't found anything that doesn't work with it yet. What that means is you can define 16 physical colours, 20 of the 4096 analog colours, and then do control break, load the software up, and the software will use the extended palette. It just doesn't realise that it's not using the original colours. Why would it? All colours except black can be redefined. All colours can be redefined except black in Teletext Note 7. The reason for that is just the way that the Teletext display is generated. and in fact I haven't picked up certain signals off the board. What it does give is 16 solid colours in mode 2. You've also got the flashing colours as well if you want them. As you mentioned, the hardware support for smooth horizontal scrolling. I actually went a bit further than single pixel. You get single pixel in mode 0, half pixel in mode 1, and a quarter pixel in mode 2. Now, there's not much real use for that because the thing doesn't do sprites. So if you move by a quarter pixel, well, the display is a quarter pixel, I suppose you can scroll slowly, but you can't really put anything on top of it. But it's there. And if you come on my stand, you'll see the Shadow of the Beast demo that uses that. So it's got blocks that scroll at different speeds, and it's doing one block at a quarter pixel, 1.5, one at a single pixel, one at 2 pixels, I think. The other thing it does, talk about the horizontal scrolling, is you can blank off the left-hand side of the display. So what that means is that this business of delaying the output so that the display scrolls to the right, you blank off a column on the left, and then set the display so that the left-hand edge of the display is now at the right-hand edge of the bit that's blanked off. You then reduce the delay and the thing scrolls to the left. What it also means is that any screen updates can be done to memory behind that column, and you don't get flickering. So if you again on my stand, I can show some demos where you'll scroll, and unlike sort of lots of BBC micro games, you don't get that flickering or juddering on the right-hand edge or left-hand edge. It's perfectly smooth. Again, that was something that was suggested by the start of the Ronvers. The other thing I did, I mentioned the attribute modes. What you get with this are more colours. So you sacrifice a bit of pixel resolution and you sacrifice some colour resolution, but you get more colours on screen. So you can do 4x4 colours, 240 by 256, 4x2 colours at 480 by 256. Notice normally you see that would be 320 by 256 or 640 by 256. You reduce the screen resolution. And there's a text-only mode that Dominic suggested. You can do 8x2 colours at 480 by 256, and that allows you to have an 80-column mode with 8 foreground colours and a background colour, which I can show you. And I mean, I quite like it, to be honest. When I'm doing stuff on the BBC, I often use that mode because it's quite attractive, I think. What I also did in ROM, I added software support for an extended VideoNuLA. For those who can remember, the syntax was VideoNuLA, logical colour, physical colour, 000. The final 3 zeros now do something because they were always there from the start. Acorn put them in, so you could program an analog palette. You can now do that. So there are a couple of forms of this. You can do VideoNuLA, don't worry about the logical colour, just set physical colour P to analog colour RGB. And you can set the logical colour as well if you want to. That's there because it mimics what I think the Archimedes does. There's a VideoNuLA command on the Archimedes that does something similar. I put in software support for the new attribute modes, which are modes 96 to 104. And so that works from BASIC and any OS legal software. So View, you can run View. It doesn't understand there are more colours available, but you can do it. In terms of use, you can change the palette of any existing software. I've got a routine in the ROM that allows you to do that. Or you can program it, from BASIC or any language. Here are some examples. So there's Firetrack, it looks like greys, and Frack, which you've got brown and a lighter pink. And a game I used to play all the time when I was a kid, actually Match Day, you've got browns and dark greens and all sorts of things. Again, they're oblivious to the fact it's doing this because they just don't expect the hardware to be there. One of the things we've been doing recently is kind of revamping old games to use 16 colours. So Kevin Edwards released the source code for his Galaforce game on Stardot, and that people were able to then take that, sorry, I did actually, and modify the graphics. So rather than using 8 colours that you used in Mode 2, to use 16 colours. And I wrote the tool that allows you to rip the sprites out of the game, modify them in a paint application, and then put them back in. So I did that for Hunchback, Killer Gorilla, using some results. So you can't see it actually. On the alpha, you can only really see the extra colours when you progress later in the game, and I'm not good enough at it to get that far. So that's the start. But there are some grey pixels in the spaceship, I can promise you. Hunchback, I changed it more like the original, so the colour scheme there are browns, dark greens, greys. I changed the sprites as well to look more like the arcade original. And Killer Gorilla, again, the gorilla rather than being red and magenta is now 2 shades of brown. And so there's colours going on, there's light pinks and greys and stuff. So there's that. In terms of other applications, Simon Morris wrote a gallery application. I've got that running on my store. Showing what can be done with 16 colours. And to be honest, I mean, the first time I saw this, I was amazed because it really brought home to me kind of the fact that on an all-greens micro, you kind of sacrifice resolution, you go to the 16 colour mode, but you don't get the sort of commensurate gain in colour space. But now you do. My wife started seeing this, she said, oh, that's better than anything you've done on your board, which cheered me up no end. But it does look amazing, you know, I mean, it really does bring home kind of just how powerful you know, the bead could have been if it had this, I guess. The other thing is, because if you want to, you can make use of extra colours and scrolling. So I've got my Shard of the Beast demo, which looks like that. All scrolls at different speeds. This works by a technique called vertical rapture, where you basically divide the frame into kind of subframes, and each frame scrolls independently. There's a palette change, there's lots of palette changes, it goes down, so you've got blocks of different colours, so there are more than 16 colours on screen here. And so they all scroll at different speeds. It's kind of replicating the Amiga game. And so it just goes to show what can be done when you've got kind of you know, a larger palette really. In terms of if you want to use this for yourself, it's actually supported partially in BM, and I think more fully in the new B2 emulator. So you can actually play with this thing without actually having to have one physically. So if you do want a physical one, I've got them for sale. You're more than welcome to buy one. But I often develop stuff for it in BM and then transfer it across to the real hardware just because it's more convenient. That's in terms of the talk. What I would say, again, for me, the big take-home point for me was really that just how much support there is out there. I started off this thinking, oh, I'll never do this, you know, it'll be kind of a wild goose chase really. But just because of the sort of encouragement and support of people and the amount of information that's out there, you know, I was able to deliver it. What I would say is, if you've got an idea, you know, don't be afraid. I was afraid, to be honest, for a long time. I thought, I can't do this. And when I realised, you know, I started actually going for it, I realised just how much help and support there is, how much information there's out there, how much people are willing to help. You know, it really made me think that, you know, I'm sure lots of people have loads of ideas of things they could be doing, and kind of, you know, quite such a support factor. Thanks.
Is your VHDL available on somewhere like GitHub?
It's not, for a couple of reasons. One, because, I'll be honest, in this environment, I've been burnt in the past for sharing stuff where I did something, I shared it with someone, and they went off and started selling it without permission of me. So I was kind of reticent to begin with to share it. And I guess, secondly, since I started making this, I've had various people come to me and say, oh, I'd like to kind of make them, you know, and initially, because I was still concerned about my ability to make them, I kind of thought, well, that might not be a bad thing. And then a friend of mine sort of said, well, look, why don't you run with this, you know, see how far you can go with it. I'm not averse to sharing stuff, to be honest, and there's probably enough detail in the manual which is online, and, you know, there's enough stuff out there that you can work out how this thing works, you know, replicating wouldn't be that hard. It's just I wanted to run with it. And I think my previous experience had been a little bit burnt by something. I just wanted to get to a point where I could sort of say, actually, you know what, I could use some hardware for BBC Micro. You know, if someone said, you know, I was 12, 13 or something, you'd do that one day, you know, that would have been kind of a big thing for me. So I wanted to get to that point. I wouldn't say I'll never release it. You know, I think there'll come a point where I'll think, okay, you know, I'll put it out there now. But for the moment, I'm kind of quite, I have to be honest, from a sort of selfish point of view, I'm quite enjoying making them and producing them. So I'm a little bit reluctant to do something more that, if people want to come to me and sort of say, you know, how does this work, or how do you get up with, I'm happy to answer questions. I just don't want to push the whole thing out.
Yeah.
Any other questions?
How much is it, please?
It's £50, which I'll be honest is I mean, you know, I guess it's relatively expensive. The big problem I had was when I started doing it, I was buying the CPLDs from China, and they were very cheap. They just didn't work, or at least 60% of them didn't work. I would find myself reworking them. They would work most of the time, and then you know, one I/O pin would be stuck high or stuck low. So I've taken to buying them from the UK, so all the parts come from the UK and they are more expensive. So about half the cost is components and half the cost is my time to assemble, program and test them. Many people.
Like £400 for a BBC in 1981.
Yeah. Well, yeah, somebody used to say to me, oh, it's a bargain. I wouldn't quite go that far, but you know, that's probably being really honest. Of course, I shouldn't say that. The pallet mate was £99 in 1986, so with inflation, I know it's a bad deal necessarily. But yeah, I appreciate, you know, it's not, you know, it's not a trivial amount of money. I mean, I think, you know, if somebody bought more than one, I give a discount on some bulk purchases kind of thing. But yeah, from my point of view, I would love to be able to say, well, I'll just make them with my spare time and kind of, you know, essentially sell them at cost price to me. My wife's point was, because I started sort of doing them when I did the first 5, she said, yeah, we don't see you any evenings, we don't see you on the weekend, you know, because it took me a long time, you know, first to make the first few. And when I was making the first batch up, and she said, I think we need something, I think kids should, you know, deserve something from this. So my kids get horse riding lessons, you know, from this. And yeah, I guess it pays for the equipment and stuff. But yeah, so they're £50 a quarter. It comes with a ROM. There's an online manual, all the bits you need to install it. I have been saying this, one thing I didn't mention at all is on the BBC B that ULA socketed, on the Master, B+, the ones I've got, compact, they're all soldered in. I've been saying to people, if you're ready to come on postage, I'll fit it for you. So anyone who's kind of worried about desoldering their ULA, I've done loads of them now, and I haven't damaged one yet. So you know, people want, I have been fitting them for free. Thanks.